Atomic orbitals are associated with individual atoms. Molecular orbitals are associated with the whole molecule. So molecular orbitals hold the electrons that constitute bonds. This vertical axis is an energy axis. Low energy at the bottom, high energy at the top. This molecular orbital is lower in energy than the atomic orbital. We can imagine an equation to describe the shapes of these orbitals. It can either have a positive value, or it can have a negative value, or it can be zero. If you multiply two negative numbers together, the result is a positive number. Psi squared, the square of this mathematical description, has only two physical attributes. The value could be positive, and that is related to the probability of finding an electron. The value can also be zero. So there's a fundamental truth here. You cannot be sure with absolute certainty where an electron is, but you can be sure where it is not. If the value is zero, then there is no chance of finding the electron there. So this symmetric combination puts the electron density where we need it to make a bond. The opposite combination is the exact opposite. And if you put electrons in there, you increase the energy of the molecule. It's working against bonding. It's anti-bonding. So let's look at the energy level diagram now. The bonding molecular orbital that is produced by combining these two is a sigma bonding orbital. It is lower in energy than the component s orbitals. The electrons, two of them for that bond, occupy that orbital with paired spins. And the second orbital is much higher in energy. When you put the electrons in, they occupy the bonding orbital, and that produces an energy gain. And it's that that's holding the molecule together.